Hello my friends and welcome back to the Today Machine channel. The hot rolling steel production industry is a critical segment in the global steel market, serving industries like automotive, construction, and energy. Hot rolling is a process in which steel is heated above its recrystallization temperature and then deformed into a desired shape, such as sheets, plates, or coils. The global steel industry, valued at over $2.5 trillion, is driven by advancements in technology, energy efficiency, and demand for high-strength, durable steel. Process overview. The hot rolling process begins with the heating of billets or slabs to temperatures around 1,200 degrees Celsius to 1,300 degrees Celsius, 2,190 degrees Fahrenheit to 2,370 degrees Fahrenheit. This high temperature allows the material to be deformed easily and shape into desired profiles like bars, sheets, and structural shapes. The steel is then passed through a series of rollers that reduce the thickness and shape the steel. Hot-rolled products typically include wide plates, structural sections, and hot-rolled coils, which are the primary inputs for manufacturing various end-use products. Market size and growth. The global production of hot-rolled steel is massive, with approximately 1.9 billion metric tons of crude steel produced annually, according to the World Steel Association. In 2023, approximately 60% of this steel was used for hot rolling, producing a variety of products such as plates, coils, and structural sections. China, the largest producer of steel, accounted for around 50% of global steel production, with hot rolling being a dominant process in their operations. India, Japan, and the United States are also significant contributors to global hot-rolled steel production. Technological advancements. Technological innovations such as continuous casting and direct rolling are key drivers of the hot rolling industry. Water manufactures steel vessels for pressure filters designed to treat water in a variety of applications, ensuring the removal of contaminants such as iron, manganese, ammonium, and aggressive carbon dioxide. These filters are essential for waterworks, industries, and households requiring water of the highest quality, whether for drinking or commercial use. The complexity of the filtration process depends on the water quality and the final use, with Water offering a range of filter media options to tailor solutions for specific needs. The pressure filters are versatile, serving a wide array of purposes, including iron and manganese removal, pesticide filtration, arsenic elimination, dechlorination, and even seawater filtration. Additionally, they are used for percolate filtration, suspended solids removal, and the final filtration of wastewater. These filters are especially beneficial in waterworks and private households with their own water sources, ensuring the water meets the required standards. Pressure filters are designed with a nature-based approach, relying on natural processes like oxidation and filtration, which contribute to a safer and more environmentally friendly operation. The use of air for oxidation eliminates the need for hazardous chemicals, creating a safe working environment. Additionally, the filters are engineered to minimize rinse water consumption, which reduces the risk of harmful effluent water, making them both cost-effective and environmentally sustainable. The product range includes both manual and automatic backwash options, with modular designs that allow for flexibility and customization based on the application's needs. The steel tanks are highly durable and coated with materials such as epoxy paint, stainless steel, or PPA coatings, offering long-lasting protection against corrosion and wear. These design features ensure reliability and safety, making Eurowater's pressure filters a trusted solution for water filtration needs. The hand-forged shovel industry in India is a vibrant example of traditional craftsmanship meeting practical needs. Rooted in rural and semi-urban areas, this sector is a cornerstone of local economies, employing approximately 50,000 artisans nationwide. It produces around 2 million shovels annually, catering to agriculture, construction, and domestic markets. The production process begins with raw materials like iron or steel, often sourced from recycled metal to maintain cost efficiency and sustainability. The metal is heated to 1,200 degrees Celsius in coal or gas forges, making it malleable enough for shaping. Blacksmiths, armed with hammers and chisels, craft each blade through precise strikes, a skill honed over generations. On average, an artisan can forge 20 to 30 blades per day, depending on complexity. After shaping, the blades undergo quenching, typically in water or oil, to enhance their hardness and durability. Handles, made from sturdy hardwoods like teak or neem, are attached using hand-carved sockets. This ensures durability and ergonomic ease for the user. Each shovel is inspected for quality, as small-scale workshops prioritize craftsmanship over mass production. Economically, this industry generates an annual revenue of approximately $15 million, with much of the production centered in states like Uttar Pradesh, Rajasthan, and Tamil Nadu. Exports account for 10 to 15% of the total output, with Indian shovels gaining recognition in markets across Africa and Southeast Asia for their quality and affordability. Despite technological advances, the industry remains labor-intensive, fostering strong community ties and preserving India's metallurgical heritage. Investment in modern equipment and better market access could significantly enhance productivity and global competitiveness, ensuring the long-term viability of this traditional trade. The fully automatic chain-link fence-making machine operates by automating the process of producing chain-link fences from wire coils. First, the wire is unwound and fed into the machine, where it is straightened and cut into desired lengths. The machine then uses a weaving mechanism to interlace the wire, creating a chain-link pattern. The woven wire is then tensioned to ensure uniformity and strength. For the red surface treatment, the wire is coated with a protective layer, usually through a process like powder coating or painting, to prevent rust and enhance durability. The machine also includes automatic cutting and coiling systems, ensuring continuous operation with minimal manual intervention, delivering high-quality chain-link fences efficiently. Haas CNC lathe hand programming is an essential skill for those working in machining, offering a hands-on approach to controlling the lathe's functions without relying on automated systems. In this context, the process involves programming the machine's movements, feeds, and speeds manually. One challenge encountered is that schools often limit the feeds and speeds during training, particularly for safety and educational purposes. This limitation can hinder the machine's full potential, but it ensures that students learn the basics before advancing to more complex settings. In this specific case, the operator is avoiding the use of coolant for filming purposes, which introduces an additional challenge. Coolant is typically used to prevent overheating and to aid in chip removal during machining, making it essential for high-speed cutting processes. Without coolant, the risk of tool wear and part defects increases, especially when performing operations like grooving. Grooving without coolant is generally considered a big no-no, due to the heat buildup that can cause tool damage or failure. To counter this, the operator starts by cutting an initial groove at a reduced feed rate, allowing the tool to engage with the material while minimizing the heat generated. This cautious approach ensures that the machine runs safely, even without coolant, while still allowing for the filming of the process. Through careful programming and attention to detail, Haas CNC lathe hand programming can effectively manage these challenges and achieve precise results. The PHC, pre-stressed high-strength concrete pile production process at the Bismaya New City project represents a significant milestone in the Middle East, as it marks the region's first production of PHC piles. These piles are critical components used in the foundation construction of housing buildings, specifically for the Bismaya housing units. The production process begins with the preparation of raw materials, which include steel bars and wires. The steel bars are first cut to the desired length and undergo a heading process to form the necessary shape for tensioning. Next, the wire is coiled around the steel bars at a high speed, creating a pre-stressed structure that provides strength to the pile. The coiled steel bars are then transferred to the case and shoe assembly section, where they are securely positioned. Following this, the piles are moved to the concrete input stage, where the mix is poured into molds. A bolt tightening process ensures that the entire setup is tightly secured to withstand the pressure during curing. The steel bars are then tensioned to ensure the pile's stability and strength. The pile moves to a rotary molding stage, where it is rotated in the mold for a precise duration of 11 minutes, ensuring even distribution of the concrete. Once the molding is completed, the pile is transferred to a steam chamber for curing, which lasts 12 hours. This process helps the concrete achieve its full strength and durability. After curing, the pile is demolded and the pre-tensioned bolts are removed. The final product is a high-strength, pre-stressed concrete pile ready for use in the construction of housing foundations. This efficient, automated production process ensures the consistent quality and durability of the PHC piles used in Bismaya New City's foundation works. Rewinding an electric motor involves a meticulous process that restores the motor to optimal functionality, making it a cost-effective alternative to replacement for large or custom motors. Here's a step-by-step overview. Initial inspection and dismantling. The process begins with a thorough external inspection to identify visible issues. Once dismantled, the motor undergoes a comprehensive examination to assess internal damage, focusing on the windings and insulation. Removal of old windings. The damaged windings are carefully removed to prevent harm to the core. Old insulation papers are pulled out, and any stubborn fragments are burned away using a blow lamp to ensure a clean slate for the new windings. Preparation for rewinding. The core is cleaned and prepared to receive new windings. This step ensures proper adhesion and alignment of the windings, critical for motor performance. Rewinding process. New windings are installed with precision. Coil ends are soldered and insulated to ensure secure electrical connections and prevent short circuits. The entire winding assembly is then varnished to improve durability and insulation. Reassembly and final steps. After rewinding, the motor is reassembled. It undergoes rigorous testing to verify electrical and mechanical integrity. Once approved, the motor is painted for protection and aesthetic appeal. Rewinding an electric motor can save up to 40% compared to replacement costs, particularly for large or custom motors. At Gibbons, we enhance this service by offering free collection and delivery within a 50-mile radius of our workshop, along with a 12-month warranty for peace of mind. The YS914 heavy-duty corrugated roll forming machine by Yun Singh operates through a systematic process designed for efficient production of roofing and corrugated sheets. The operation begins with raw material feeding, where the power and hydraulic system are activated to initialize the machine. The uncoiler on function establishes a secure connection between the uncoiler and the machine, while the feeding on function unlocks the safety lock to allow the raw material to be fed into the system. The operator uses a remote control to advance the material through the uncoiler and adjusts the guide table to ensure proper alignment. Once aligned, the material is forwarded automatically to the cutter, where the center adjust function is used to trim the front edge for accurate processing. In the length correction and production phase, the operator presses Edit to test a single sheet by setting a length of at least 1 meter. The produced sheet is measured, and any discrepancies are corrected using the parameter function to adjust the error coefficient. After the adjustments, production continues seamlessly, ensuring each sheet matches the required specifications. The machine also features a pre-cutter function for efficient coil changes without material waste. When activated, The pre-cutter automatically trims the material at the designated length, allowing production to continue smoothly as new coils are fed into the system. This feature ensures precision and minimizes downtime, making the YS914 an efficient solution for large-scale corrugated sheet production. Continuous casting, which accounts for approximately 95% of global steel production, has enabled greater production efficiency and energy savings. The shift to modern electric arc furnaces, EAF, and hybrid processes has also played a significant role in reducing energy consumption and improving product quality, especially in the production of high-strength and specialized alloys. Production facilities and capacity. Hot rolling mills are usually part of integrated steel plants or specialized rolling mills. The size of these plants varies, with some of the largest facilities having an annual hot rolling capacity of over 10 million tons. For instance, the Tata Steel IJmuiden plant in the Netherlands is capable of producing over 6 million tons of hot-rolled steel products annually. Smaller, specialized mills focus on niche markets, such as the production of high-strength steel for automotive applications or advanced alloys for aerospace. Challenges and sustainability. The hot rolling industry faces challenges related to energy consumption, environmental impact, and cost pressures. Energy usage can reach up to 4 gigajoules per ton of steel produced, with a significant portion derived from fossil fuels. As a result, there is increasing pressure on producers to reduce carbon emissions and improve efficiency. The industry is increasingly investing in electric arc furnaces, waste heat recovery systems, and cleaner technologies to meet these sustainability goals. The construction of the SUEZMAX tanker Monte Urbasa at Navantia's Puerto Real shipyard in Cadiz is a remarkable display of modern shipbuilding. Built in 2018 for the Grupo Incredibel, this vessel exemplifies precision engineering and innovative design in maritime construction. The time-lapse of its construction captures every phase of this massive project, from the assembly of individual steel blocks to the integration of critical systems. At 274 meters in length and 48 meters in beam, Monte Urbasa boasts a summer deadweight capacity of 156,400 tons, making it a powerful asset in global shipping. The ship's sleek design and engineering cater to the demanding requirements of transporting crude oil efficiently across the world. The process begins with the fabrication and assembly of modular blocks, which are then welded together to form the ship's hull. Following this, key systems such as propulsion, navigation, and cargo handling are installed. Rigorous testing ensures compliance with international safety and performance standards. Finally, the vessel is launched, outfitted, and delivered. During the sea power demonstration aboard the USS Stennis, CVN-74, Tiger cruise, the USS Dewey, DDG-105, experienced a dramatic moment as it dipped its nose into the water. The maneuver, part of a series of impressive naval displays, showcased the ship's agility and precision. This unexpected yet controlled dip added excitement to the demonstration. Highlighting the capabilities of the ship and the skill of its crew during the high-profile event. The wreck removal of the Baltic Ace was a significant and complex maritime salvage operation, necessitated by its collision with the container ship Corvus J in the North Sea. The sunken wreck obstructed one of the world's busiest shipping lanes, leading to environmental and navigational risks. The Baltic Ace carried 1,417 cars and held approximately 540,000 liters of oil, raising concerns about potential leaks. Complete removal was deemed essential to restore safe passage and mitigate environmental threats. In 2014, the removal commenced with the extraction of oil from the wreck. Using a hot tap method, the solidified oil was heated and pumped out, successfully removing over 456,000 liters from accessible tanks within 2 weeks. The wreck was then prepared for salvage by divers who cut holes in its hull and inspected its structural integrity. However, extensive damage necessitated changes to the original plan of lifting the wreck in 6 large sections. The salvage operation, executed between March and October 2015, employed advanced techniques. A specialized wire cutting system divided the wreck into 8 sections, using cutting wires up to 120 meters long. Two floating barges, equipped with a heave compensation system, were used for flexibility amid wave motion. The stern and bow, the largest pieces, were lifted first, while weaker sections were extracted using a salvage grab. Heavy storms caused delays, but work proceeded with precision and adaptability. By late August 2015, the wreck and debris, totaling nearly 13,000 tons, were removed. Divers and scans ensured a clean seabed. The wreckage was dismantled sustainably, with materials sorted and recycled. The seabed was cleared by October, and the shipping lane reopened in November, ahead of the December deadline, restoring safe and efficient maritime traffic. The forging industry in the Czech Republic has long been a cornerstone of its manufacturing sector, contributing significantly to the nation's economy. As of 2024, the industry is experiencing a period of transformation, driven by technological advancements, strategic investments, and evolving market demands. Industry overview. The Czech forging industry is integral to various sectors, including automotive, aerospace, industrial machinery, and construction. While specific national statistics are limited, global market trends provide context for the industry's trajectory. The global metal forging market was valued at approximately $82.3 billion in 2022 and is projected to reach $158.8 billion by 2032, growing at a compound annual growth rate (CAGR) of 6.8% during this period. In the Czech context, the aluminum forging segment is poised for growth between 2024 and 2030, driven by demand in sectors such as automotive and aerospace. Technological advancements. The Czech forging industry is embracing technological innovations to enhance efficiency and product quality. The integration of Industry 4.0 technologies, including automation, artificial intelligence, AI, and digitalization, is becoming increasingly prevalent. These advancements enable real-time monitoring, predictive maintenance, and optimized production processes. The Czech government has demonstrated a commitment to fostering technological development. In 2024, it announced an 8% increase in the research and development (R&D) budget, raising it to €1.72 billion. This funding aims to support early career scientists and initiatives in strategic fields such as AI, quantum technologies, and advanced manufacturing. Additionally, the National Artificial Intelligence Strategy of the Czech Republic 2030, NAIS, underscores the country's ambition to become a technological leader, with implications for the forging industry in terms of adopting AI-driven manufacturing processes. Recent developments. A notable development in the Czech forging sector is the acquisition of Czech Precision Forge AS, a Pilsen-based forge specializing in die and free forging. As of November 1, 2023, the company was acquired by a consortium including the MANSAKO Group, CE Industries, and the investment fund Meiji Investment Sikiv. The new owners plan to invest in technology, increase productivity, and expand the customer base across various industry segments. Market dynamics. The Czech forging industry is influenced by both domestic and international market dynamics. The global metal forging market is expected to grow from $94.74 billion in 2023 to $101.93 billion in 2024, at a CAGR of 7.6%. This growth is attributed to factors such as the expansion of the automotive industry, increased infrastructure investments, and the adoption of lightweight materials. In the Czech Republic, the automotive sector remains a significant consumer of forged components. The shift towards electric vehicles, EVs, presents both challenges and opportunities for the forging industry. While EVs require fewer forged parts compared to traditional internal combustion engine vehicles, there is a growing demand for lightweight, high-strength components to enhance vehicle efficiency. Challenges and opportunities. The Czech forging industry faces several challenges, including the need for modernization, increasing competition, and the necessity to meet stringent environmental regulations. The industry's relatively low degree of automation and high reliance on manual labor, as highlighted in the case of Czech Precision Forge AS, indicate areas requiring improvement. However, these challenges also present opportunities. Investments in advanced technologies, such as AI and automation, can enhance productivity and product quality. The government's increased R&D budget and strategic focus on technological innovation provide a supportive environment for such advancements. Furthermore, The global trend towards sustainability and carbon neutrality is driving demand for forged components in renewable energy sectors, such as wind and solar power. This shift opens new markets for Czech forging companies willing to diversify and adapt to changing demands. The role of the Czech Forging Industry Association, SKCR, and issues related to forging technology. The Czech Forging Industry Association, also known as SKCR, plays a pivotal role in shaping and advancing the forging industry in the Czech Republic. As a regular member of the European Forging Association, EUROFORGE, SKCR serves as a vital link between Czech forging companies and the broader European and global markets. This association brings together key players in the forging industry, suppliers, and research institutions to address the challenges and opportunities in forging technology. Key functions of SKCR: representation and advocacy. SKCR represents the interests of Czech forging companies on both national and international platforms. It advocates for policies that support the growth and competitiveness of the forging sector, emphasizing sustainability and technological innovation. Collaboration and networking. By fostering collaboration among its members, SKCR promotes the exchange of knowledge and best practices. This collaboration extends to partnerships with research institutions and universities, such as the Research Center for Forming Technologies, Fortech, and the Faculty of Mechanical Engineering at the University of West Bohemia in Plzeň. Support for innovation and development. The association emphasizes the importance of research and development, R&D, in advancing forging technologies. Key R&D contributors include organizations like COMTESFHT in Dobrany, which focus on material testing, process optimization, and the development of new forging techniques. Market development. SKCR aids its members in penetrating new markets, particularly in high-demand sectors like automotive, aerospace, hydraulics, and machinery manufacturing. Overview of the Czech forging industry. The Czech forging industry is integral to the national economy, with an estimated annual production of 300,000 tons of forged products. The industry's mainstay is die forging of steel components, which constitutes over 75% of the output. The automotive sector is the largest consumer of forged parts, accounting for approximately 60% of production. Leading companies in Czech forging. Moravské Kavárny, Jihlava, specializes in high-volume production of automotive forgings. MSV Metal Studenka, known for its expertise in railway and industrial forging. Kavárna Viva, Zlín, focuses on precision forging for hydraulic systems. ZDA's Zidar nad Sazévu, a leader in heavy forging for machinery and industrial applications. Strojmetal Aluminium Forging, Kamenis. A pioneer in aluminum forging for lightweight automotive components. Challenges in forging technology. Sustainability. The forging industry faces growing pressure to adopt sustainable practices. Energy consumption and carbon emissions are critical concerns. Czech companies are increasingly investing in energy-efficient furnaces and exploring renewable energy sources. Workforce development. The industry struggles with a shortage of skilled labor. To address this, SKCR collaborates with technical universities and vocational schools to promote careers in forging. Technological advancement. The rapid pace of technological change requires companies to continuously upgrade their equipment and processes. Advanced forging technologies, such as closed die forging and isothermal forging, are gaining traction but require significant investment. Global competition. Czech forging companies compete with manufacturers from countries with lower labor costs. SKCR emphasizes the need for innovation and quality to maintain a competitive edge. Innovations and future trends. Automation and digitalization. The adoption of Industry 4.0 principles, such as robotics and real-time data monitoring, is transforming the forging process. For example, companies like Czech in Czech are integrating automated systems to enhance efficiency and reduce waste. Advanced materials. The development of new alloys and composite materials is opening up opportunities for lighter, stronger, and more durable forged components. "3D printing and hybrid manufacturing." Combining traditional forging with additive manufacturing is emerging as a promising avenue for producing complex and customized parts. Eco-friendly forging. The focus on reducing environmental impact is driving the use of cleaner production methods, such as electric furnaces and closed-loop cooling systems. Statistics and economic impact. The Czech forging industry contributes approximately €1.2 billion annually to the national economy. It employs over 10,000 workers, with indirect employment supporting an additional 20,000 jobs. Over 70% of Czech forged products are exported, primarily to Germany, Austria, and France. The role of suppliers and research institutions. Suppliers of forging equipment and materials play a critical role in the industry's success. Companies like Exova, Polzen, and Praha provide essential tools and materials that enable efficient production. Research institutions, such as Fortec and COMTES-FHT, are instrumental in addressing technical challenges. Their work on process simulation, material testing, and heat treatment optimization has led to significant advancements in forging technology.